The world we perceive might be nothing more than an illusion. Physicists have suggested that the reality we experience may not be as genuine as we think. Our thoughts and perceptions feel real, but from a scientific standpoint, everything we experience could be a carefully constructed illusion, made for us to perceive. We may live within this illusion and explore it, but we are on the verge of discovering the truth behind the greatest deception: the nature of matter. Is matter truly real? It appears so when we place a plate on the table and it stays in place. We can bring food to our bodies, where digestion occurs and provides us with energy. There's no doubt that the world of matter exists in some way. After all, we can even harm ourselves with weapons or destroy our bodies in the material world. But recent scientific findings challenge our traditional view of matter. Studies suggest that the material world is no more than a projection designed for us to experience. We might be much more than we appear to be. In fact, we could be something entirely different from our mortal bodies, which are merely physical vessels for our consciousness. Traditionally, scientists have believed that when the body is destroyed, the individual ceases to exist. But there is growing evidence suggesting that our bodies may merely be constructs in a three-dimensional space, possibly influenced by something we might call a soul. Just as a symbol exists in multiple forms, we might simultaneously exist in another universe, dreaming our lives as symbols on Earth. In this case, our physical world could be nothing more than a puppet show, and we could be players in a much grander reality, though most of us remain unaware of this. Einstein's theory of relativity, which describes the universe in terms of space and time, has long been considered a cornerstone of modern physics. However, newer theories like quantum gravity and string theory challenge some of Einstein's ideas. Relativity and quantum mechanics often contradict each other, suggesting that there may be deeper levels of reality that bridge the two. The study of quantum mechanics, which governs the smallest particles in the universe, has revealed phenomena that do not fit within Einstein's framework. For example, quantum particles behave differently than matter, suggesting that what we perceive as matter may not be as real as we think. Furthermore, new discoveries from the James Webb Space Telescope are challenging our current understanding of physics. These findings cannot be explained by traditional theories, indicating that Einstein's ideas may be incomplete. Quantum mechanics reveals phenomena that relativity cannot explain, such as black holes and singularities, which defy the general theory of relativity. The mysteries of dark matter and dark energy remain unsolved, and both space and time may be more fluid than previously thought. In recent years, it has been proposed that the forces of gravity may not be a conventional force at all, but rather a curvature of spacetime caused by the presence of mass and energy. Some researchers suggest that reality itself could be made of tiny, quantum-like structures that act in ways we don't yet fully understand. These structures could possess some form of intelligence or represent a kind of life that we have yet to comprehend. Moreover, evidence suggests that the forces of the universe may have evolved over time, indicating that the universe itself could be undergoing a kind of growth similar to life. While Einstein's work remains a significant milestone, the quest for a unified theory of everything continues. However, if the universe is indeed an empty projection like some have suggested, our chances of understanding it through traditional physics are limited. To truly unlock the mysteries of the universe, we may need to embrace new methods of science, possibly involving higher levels of consciousness or completely new paradigms of thought. One such theory, the holographic universe hypothesis, proposes that all the information required to create our three-dimensional universe is stored on a two-dimensional surface at the edge of the universe. This idea has its roots in both quantum mechanics and general relativity. Quantum mechanics suggests that quanta, the smallest units of light, can behave like particles and waves, and they possess the remarkable ability to dissolve back into a wave state if they are not observed. In a holographic universe, this means that objects like a table would cease to exist as solid matter when not being observed, essentially vanishing from existence. The holographic universe theory argues that our three-dimensional world is a projection of data stored on a two-dimensional surface. This idea stems from studies of black holes, which showed that the amount of information contained in a given volume of space is limited by the surface area of that space, not its volume. This contradicts traditional views of space and suggests that the dimensions themselves might be part of a larger, more complex framework. In practical terms, This means that the universe we experience, with its material objects and physical phenomena, could be an illusion projected from a two-dimensional surface at the edge of the universe. Gravity, in this context, would not be a traditional force but a consequence of this projection. Our consciousness plays a key role in shaping the universe we perceive. We experience reality through our minds and senses, but we may never truly understand what is out there, since we only see what our minds allow us to. In this holographic view of the universe, consciousness is central. Though scientists don't fully understand the nature of consciousness, it seems to play a crucial role in the transformation of quantum particles from waves to solid matter. Perhaps consciousness itself is the fundamental force that shapes and supports the universe. Our individual consciousness may be part of a greater, collective consciousness that co-creates the universe with us. In this scenario, we are both experiencers and creators of reality. While the idea that a table vanishes when not observed has not been scientifically proven, it highlights the power of consciousness in shaping our perceptions of reality. If the speed of light, once considered a constant in the universe, is truly variable in this framework, our understanding of reality would be forever changed. Ultimately, if the universe is indeed a projection of data and consciousness is fundamental to shaping reality, our current understanding of the world may be incomplete. The speed of light, the nature of gravity, and the role of consciousness all suggest that we may be on the cusp of a new understanding of the universe, one that goes beyond the physical design
of
laws
the
we have
universe,
known for centuries.
the role of awareness,
And the governing principles that regulate existence continue to fascinate as humanity stands on the periphery of this logical frontier. The pursuit of a unified theory of everything remains an unyielding quest, particularly the challenge of merging quantum mechanics with general relativity. This pursuit compels scientists to push beyond traditional boundaries, exploring unconventional theories and pioneering new methods that could ultimately reveal the true nature of the universe. One of the most provocative ideas emerging from modern physics is the notion of a holographic universe. This theory suggests that our three-dimensional reality could be a projection of information encoded on a two-dimensional surface, akin to how a 3D image is projected. The idea originated from efforts to reconcile quantum mechanics with Einstein's theory of general relativity, particularly in the study of black holes and their thermodynamics. Researchers noticed that the information content of a black hole's event horizon seemed to be proportional to its surface area, not its volume. This observation led to the proposal that the universe itself could be viewed as a multidimensional image, where all the data that constitutes our reality is stored on a distant boundary. The holographic principle suggests that everything we perceive in the universe, planets, stars, galaxies, could be no more than a three-dimensional projection of data stored on a cosmic horizon. This concept challenges our fundamental understanding of space and time, implying that these dimensions may emerge from a deeper, more fundamental structure at the edge of the observable universe. Additionally, the holographic principle hints at a profound interconnectedness between all parts of the cosmos, where every point in space could be intricately linked to every other point through a fundamental informational network. This could potentially explain various astronomical mysteries, such as the uniformity of the cosmic microwave background radiation and the large-scale distribution of galaxies. Recent advancements in theoretical physics, especially in the fields of quantum gravity and string theory, provide further support for the holographic idea. String theory, for example, posits that the fundamental particles of the universe are not point-like objects but rather tiny vibrating strings. These strings exist in a higher dimensional space, which might accommodate the holographic nature of the universe. The idea of a holographic universe also raises intriguing questions about the nature of consciousness and perception. If reality is indeed a holographic projection, our experience of the world could be analogous to watching a movie, appearing real, yet fundamentally constructed from light and information. Consciousness, in this view, could be the process by which we interpret and engage with this projected reality. The implications of this idea extend beyond theoretical physics into philosophy and metaphysics, challenging traditional dualistic notions of mind and matter and suggesting a more integrated perspective where consciousness and the physical universe are intertwined. This perspective aligns with ancient philosophical traditions that view the universe as a unified whole, where each part reflects the sum of the entire system. The holographic principle encourages us to reconsider the role of perception in shaping our understanding of reality. Quantum mechanics has already shown that the act of observation can influence the behavior of particles, a phenomenon known as the observer effect. In a holographic model, this effect could imply that our perceptions not only reveal aspects of reality but also actively participate in its creation. Practically speaking, exploring the implications of a holographic universe could revolutionize how we understand and manipulate spacetime and matter. It might inspire new technologies based on the manipulation of information and quantum principles, leading to advances in computing, communication, and even our understanding of consciousness itself. However, the holographic principle is not without its challenges and criticisms. Some argue that the idea remains speculative, lacking direct experimental evidence. While indirect support comes from studies of black holes and quantum entanglement, direct observational proof of a holographic universe remains elusive. Ongoing research and experiments, such as those conducted with advanced telescopes and particle accelerators, continue to test the fundamental nature of reality. In conclusion, the concept of a holographic universe challenges us to reconsider the basic tenets of existence, from the nature of reality to the role of consciousness in shaping our perceptions. It invites us to explore new avenues of scientific inquiry and philosophical thought, offering the potential for deeper insights into the profound mysteries of the universe. As our understanding progresses, so too may our perception of ourselves and our place in the vast cosmic tapestry. The universe has long been understood through the lens of scientific principles, but recent developments suggest that our current understanding might be incomplete. The relationship between time and space is often viewed as relative to the observer, with the speed of light being a key constant. However, if the nature of light is radically different from our current perceptions, this could challenge everything we've learned over the past century. Light, often described as quantum particles, photons, behaves in unpredictable ways, which raises the question of how the speed of light can be considered a constant. What if our long-held assumptions about the speed of light are flawed? If light is more dynamic and adaptable than we think, it could revolutionize our understanding of the early universe. For example, the speed of light directly affects how we measure distances and times in space, and any variation in this speed would invalidate current models of the universe's expansion. Current methods of determining the age and size of the universe, such as measuring the redshift of light, rely on the assumption that the speed of light is constant. If this assumption is wrong, our calculations and understanding of the cosmos could be off. This might explain why the James Webb Space Telescope is revealing galaxies that shouldn't exist according to traditional models. Light from distant galaxies stretches as the universe expands, and its redshift helps us estimate their age. But if the speed of light varies, then our estimations are fundamentally flawed. This doesn't mean that the pioneers of modern cosmology like Einstein and Hubble were wrong or dishonest. They based their theories on the best data available at their time. These theories worked for nearly a century, but now they seem to be incomplete. To move forward, we need to rethink our scientific models and consider new possibilities. One such possibility is the concept of a holographic universe. This theory suggests that the universe we experience may not be as solid or material as it seems. Instead, it could be a projection from a two-dimensional surface, where all information about our three-dimensional reality is encoded. In this view, gravity and other forces are seen not as intrinsic properties of matter but as phenomena arising from this holographic projection. Another area of ongoing exploration is the role of consciousness in shaping our perception of reality. Quantum mechanics suggests that particles can exist in multiple states at once, and that observation itself can alter the outcome of an experiment. This implies that our conscious awareness could be intertwined with the fabric of the universe, influencing how we perceive and understand it. Moreover, the challenge to the constancy of the speed of light isn't the only disruption to established physics. New theories such as quantum gravity and string theory are challenging Einstein's unified view of the universe. At the smallest scales, quantum mechanics reveals a reality where traditional laws of physics break down, and phenomena like particles being in multiple states simultaneously become common. The holographic universe theory also challenges our traditional view of space and time. It suggests that the entire three-dimensional universe could be a projection from a two-dimensional boundary, much like a hologram. This would mean that what we experience as solid three-dimensional matter is actually a complex interplay of information encoded on a cosmic surface. The intersection of these new ideas, particularly the evolving role of consciousness and the potential variability of key constants like the speed of light, suggests that our current models of the universe are just the beginning. As technology advances, especially with the development of quantum computers, we may uncover new ways of understanding the universe and the hidden forces that shape it. These tools could help us delve deeper into the mysteries of reality, possibly revealing that the universe is far more complex and more interconnected with consciousness than we ever imagined.